after the preparation of glycerol, we'll come to the properties of glycerol. So glycerol, as you can see, if you write the formula, a lot of things will be clear to you. CH2H, single bond, CHOH, single bond, CH2H. Now this is your primary carbon atom, 1 degree. This is your secondary carbon atom. This is also your primary carbon atom. We call it as alpha, beta, and we call it as alpha dash. Or we can say alpha, beta, and alpha dash. Okay, as you wish. So you can see here we are having two types of carbon atom, primary as well as secondary carbon atom, which is attached to OH group. So glycerol gives a reaction of both primary alcohol as well as it gives a reaction of secondary alcohol. Alright, glycerol, it gives a reaction of both primary alcohol as well as it gives a reaction of secondary alcohol, because it contains the two carbon atoms, primary as well as the secondary carbon atom. You can see it here. Here also same thing. Okay, first of all you need to understand this. But here this carbon atom, the secondary carbon atom, is less reactive in nature. Why it is so? Why it is less reactive in nature? Because here you can see here attached to the secondary carbon atom we are having two symmetrical groups, CH2H and CH2H. Two symmetrical groups are attached to the secondary carbon atom. Symmetrical groups, similar groups. Due to this reason, this particular carbon atom is quite stable in nature. It is stable due to symmetry. This particular carbon atom is quite stable in nature. It is stable due to symmetry. Got it? The secondary carbon atom. Understood? Due to the presence of the two symmetrical groups. So you will find it out in the case of glycerol, the reactions that this two primary carbon atom, it reacts quite, that is efficiently it quite reacts. Under ordinary conditions it reacts, but this one it requires some other conditions. So we can say that. Clear? So that you need to understand first. Now next is, if you see the properties of glycerol, the physical properties basically of glycerol, if you find it out, then you will see glycerol due to the presence of 3 OH group. It is having extensive intermolecular hydrogen bonding. Extensive. In monohydric only 1 OH group is there. In dihydric 2 OH group is there. In trihydric it is 3 OH group is there. Due to the presence of extensive intermolecular hydrogen bonding, it is highly viscous in nature. Viscous, you understand the meaning of viscosity? Means it is a thick syrupy liquid. If you put it on the floor, then what you will find is that it does not travel so fast, because it's a quite thick liquid due to the presence of the extensive intermolecular hydrogen bond. Next, glycerol due to the presence of 3 OH group, it is having high boiling point and as well as it is highly soluble in water. So for that reason you will find glycerol is highly soluble in polar solvent like water. It is not soluble in non-polar solvent like your ether or your toluene or your benzene or your kerosene. It is not soluble. It is soluble in polar solvent due to the presence of the 3 OH group. Alright, because it can undergo intermolecular hydrogen bonding with water. Because if I take water here, so it will undergo intermolecular hydrogen bonding with water. This particular one. Okay. So for that particular purpose, it is highly soluble in water, and due to that reason only, due to the presence of extensive intermolecular hydrogen bonding, it has got high boiling point. Why? Because here 3 water can be attached, 1, 2, 3, due to intermolecular hydrogen bond. Now to what you can say, boil that particular glycerol, a solution of glycerol, you need to break the 3 bonds. Large amount of energy will be required. Due to this reason, it has got a high boiling point compared to ethylene glycol, which has got 2 OH group, compared to what you can say propanol or ethanol, which has got only 1 OH group. Alright, remember this particular thing. Comparing and I am saying you. So in this way, glycerol has got a high boiling point due to the presence of intensive intermolecular hydrogen bonding, because it readily forms intermolecular hydrogen bond with water. And as a result, large amount of energy will be required, because you think of here 3 water molecules will be there. So you need to break that particular bonds while heating it. So definitely in case of glycol, 2 bonds it will be break. In case of ethanol, only 1. And in case of glycerol, 1 molecule requires 3. So definitely the energy is more. Energy is more means boiling point is also more in this way. So, and glycerol, remember it, it is a non-toxic in nature. It is a transparent liquid. It is hygroscopic. It absorbs moisture. Glycerol, it is hygroscopic. It is transparent. It is a clear liquid, and it is viscous, and it is also non-toxic in nature. So these are the physical properties of glycerol. We can say that. Clear? Now coming to the reactions. So glycerol, just unlike other alcohols, it reacts with sodium, alright, to liberate the hydrogen gas. It reacts with sodium. So that is, if you take CH2OH, single bond CHOH, single bond CH2OH, and react with sodium, if you heat it with sodium, clear, then what is going to happen? Just now I said you, you will be getting CH2ONa, single bond CHOH, single bond CH2, that is another ONa, you will be getting it. Okay, you will be getting this in this way. Clear? If you are having only one sodium, then it is one known as what? Monosodium glycerolate. Monosodium glycerolate. Now, if I replace this hydrogen another with sodium, it will be known as what? Disodium glycerolate. It is said to be S. And if I take a higher temperature, listen carefully. If I take a higher temperature, alright. Now, this is being taken in presence of sodium. It's simply heated. Alright, if I take a higher temperature means, let us say around 400 Kelvin if I am taking it, then this H is also being replaced. Just now I said it, this is not done under ordinary conditions, under some higher conditions. So this H is also replaced by sodium and we get trisodium glycerolate. Understood now? In this way. Now, next is when it reacts with HCl. When it reacts with HCl. So, and I forgot to say you, with sodium when it reacts, that hydrogen is replaced by sodium. So, hydrogen gas is also being released. Due to this reason, it's proved that glycerol is also acidic in nature, because the liberation of hydrogen gas proves that glycerol contains hydrogen and is also acidic in nature. Okay? Got it? You have learned it in the previous alcohol and glycol, you have learned it. There also hydrogen gas is released, which proves that it is acidic in nature, isn't it? Okay, fine. Now next is, here it reacts with HCl. Let us say I am taking HCl at 383 Kelvin, I am taking it. So what will I get it here? CH2Cl, single bond CHOH. Here the chlorine will not be replaced and I will be getting a CH2Cl. Alright. So what I will get it? Alpha alpha dash. Alpha alpha dash or alpha alpha dash. Dichloro. 2 chloro is there. Alpha alpha dash. Dichloroglycerol. Alright, or dichloropropantol, alpha alpha dash dichloropropantol, or you can also say in this way 1 2 3 or 1 2 3 1 3 dichloropropantol, isn't it? We can say that in that way. Achha. Here we can also get it CH2Cl, single bond, that is CH2, what is that? I can write it here, CH2Cl, single bond CH2OH. I can write it this way also. Alright, one more product will be there. One will be a major product, this will be a major product, and this will be a minor product. This major, this is minor product. If I take excess of HCl, if I take it, excess of HCl, if I take here, then what will I get it is that I will be getting here, that is nothing but all the 3 OH group will be replaced by chlorine. If I take excess, fine. Now, next is if I take here HI. If I take HI, now see, the reaction will be a little bit different, because iodine is a bigger atom and HI is much more reactive than HCl, you know that. So if I take HI, then what is going to happen? See here, CH2, that is I, let us say, and here also that is nothing but CHI, and let us say here that is CH2OH. Okay, CH2OH, single bond CHOH. So here 2HI I will be taking, because 2 iodines is there, and this 2 hydrogen reacts with this OH and this OH to form 2 molecules of water. Now look here, you know that here, that is, iodine is a bigger atom, chlorine is a smaller compared to iodine. Iodine is a bigger atom. So when these 2 bigger atoms will come closer to each other, they will repel. They will repel one another. Steric hindrance will be there. So hence, this 2 iodine will be released, minus I2. And what I will be getting it? What I will be getting it? I will be getting it nothing but, that is CH2 double bond CH, single bond CH2OH. This is nothing but, what is that? We got it. 2 iodines are released and we get it, allyl alcohol. Now remember it, if you can, in the first step, yeah, as I have done it is there, 2 that is OH, 2 iodine and 1 OH is taken. If I take a 3HI, then you will be getting CH2I, single bond CHI, single bond CH2I. Let me tell you. See, if I take a 3HI, listen carefully. If I take 3HI, then the 3 OH group will be replaced. 1, 2, 3. And you will be getting CH2I, single bond CHI, single bond CH2I. That is an excess of HI. Mind it, excess of HI, I will be getting this. But here I am not taking excess of HI. Okay? Are you following what I said? So, here, you got this particular one. Now, next, if you again react with HI, let us say again I will react with HI, then what will happen? H will, according to Markovnikov's rule, H will be added here, CH3, and iodine will be added here. that is your CHI single bond, that is CH2OH. Okay, so you will be getting this particular one. Now next, again, if I react with HI, if I get this particular one, that is CH3, here CH3 at CHI and CH2OH. Fine. Now what will happen is that here, that is I is there, alright, and iodine is there. Now here also I want an iodine. Here also I want an iodine. So again I will react with HI. Definitely, if I want iodine here, what will I do? I'll react with HI. So what will happen is that, are you following what I am saying? CH3I, CHI, and here it is also, what is that? CH2I. Alright, CH2I it will be. So what will happen is that here this H and this OH, this H and this OH, you can see this H and this OH will react to give you what is that? Water. And again it will be unstable. If I want, I can do it, but it will be again, what is that? Unstable. Are you following? Here this is quite stable, but what I said, if I want that here OH should be replaced by I, then what will I do? I have to react with another HI. So what will happen is there, here water will be released and you get CH3 as it is, CHI as it is, and CH2I we get it. Again iodine they will repel one another. Again I2 will be released, because what I said to you, if I want, because this is quite stable, if I want then it will be possible. But if it is possible, then what will happen? It will form an unstable product. So hence what will I get? CH3 double bond CH single bond, that is CH3 single bond CH double bond CH2 you will be getting. See, iodine will be released, this 2I2 will be released and we will be getting this particular product. CH3 single bond CH double bond CH2, that is propene you will be getting it. In this way, it depends upon the conditions that how the reaction is being carried out. As I said, 3HI, I will be getting 3 iodine here. If I take 2HI, I will be getting this, and accordingly you will get allyl alcohol. Then after that HI to give you this particular product. Here iodine is being coming and OH you are getting it here. If I want to remove the OH, that is possible. But again, there is the same thing. Iodine will be removed and you will be getting again propene. You will be getting it. So in this way, under different conditions, it depends. Now see. Questions comes according to the conditions. Under different conditions, you will be getting it. The question. Suppose if I am saying 3HI, then you write this. So if you are saying 3HI, then what will happen? This I2 will not be released. Yes, of course it will be released. If I take here 3HI, then also the I2 will be released. Alright, then also the I2 will be released. Mind it. Okay, that is it. So in this way, here you will be getting I and this I2 will be released. Definitely, because I and I, when they come close together, they suffer steric hindrance. That is steric repulsion. So understand that. In 3HI also that same thing is going to take place, 2HI also the same thing is going to take place. Only the difference is that in case of 3HI, here you will be getting iodine. And in case of 2HI, you will be getting here OH. That's the difference. Here you will be getting, if iodine is coming, you will be getting allyl iodide. Here allyl alcohol I have written, you will be getting allyl iodide. That's it. So it depends upon the condition completely. The question is going to come. And accordingly you are going to write the reactions. Have you understood the concept? I am giving you the concept to you, that whatever the question comes, in whatever way the question comes, you need to write in this way. Thank you.